Hi, my name is Nathan James. My inspiration for this project was the Christchurch City Council water restrictions which have been placed on homeowners, and from the irrigation debate that is prominent in the Canterbury region. Water is a scarce resource, and my aim was to create a product that would help to conserve it while getting the maximum benefit from it. My aim was to create an intelligent watering system that would irrigate what you want, where you want, when you want, how you want. Standard water sprinklers spray out water in a uniform fixed pattern. The problem with this is, if the area being irrigated is non-uniform or does not fit the sprinkler's pattern, water is wasted. My product is iWater. My design brief for iWater was to create an irrigator that would be programmed to water a user-defined area at a user-defined rate. The standard water sprinkler is operated by water pressure. In more sophisticated versions, water pressure turns the head. In order to be able to control the sprinkler head's rotation, I had to use a motor as opposed to water pressure to power the rotation. The iWater system consists of two motors, which control position and water pressure. Both motors are controlled by an Arduino board via a motor shield. To enable unhindered rotation of the sprinkler head, I linked it to the motor with a series of gears. In order to control the distance water is sprayed, I used a flow meter to measure the water pressure and then adjusted the water valve accordingly. I coded iWater in Sketch. Code was written to control the positioning motor based on the amount of time it took the sprinkler head to rotate. Code was written to control the water valve based on the amount of time it takes to open and shut the valve. When the water flow meter is used, the code will adjust the water valve to get the appropriate water pressure for the required distance. This is proven to be problematic because only fine adjustments need to be made, and the motor used is not precise enough for obtaining accurate adjustments. Working with electronics and water is always a challenge. I have had to join together an assortment of different components with different fittings while maintaining water tightness. In true Kiwi ingenuity, I have used a series of lampshades to encase the system and protect it from the elements. To run iWater, users download the individually defined watering program via smartphone app to iWater via Bluetooth. In order to more accurately calibrate iWater's movement and to more precisely define the watering area, both motors need to be replaced with stepper motors. In the future, I would also like to look at developing moisture sensors which could communicate with iWater and adjust the watering plan accordingly. A more user-friendly interface also needs to be developed. iWater could also be applied to oxidation pond sprayers. iWater's ability to define where and how water is sprayed could be applied to dairy farming effluent systems, particularly when gravelly soils which are free-flowing.